Hi guys, welcome to a video. Is it a problem solving video? Yes, in this video I'm not really going to do any teaching. I'm just going to guide you to solve some questions on circular measure. So basically this circular measure with math file. In this video we'll solve as many questions as possible. I've got with me 17 or 14? I think 14 different questions on circular measure, and these are all paper 2 questions, which means that we're going to use a calculator for this video. And I doubt if we're going to finish all those 14 today, but we'll try as much as possible to solve as many that we can. And let's look at a time range between 20 to 30 minutes. So if you can spare me 20 to 30 minutes, I can take you through some circular measure questions. So I would put to the screen either to the right or to the left, so I'll decide when I'm doing the editing for the video. There are 7 formulas that you need for circular measure. So with circular measure, it's not just 7, we can get more formulas, but I feel that these 7 formulas are the main things that you should have at your fingertips if you want to be successful with the topic. So let's dive into the very first question. Let me zoom in. Okay, so this is the question. The question is talking about a diagram that shows a sector AOB of a circle with center O, and the radius of the sector is given by 7 centimeters, and the angle AOB is pi over 4 radians. We have to find the perimeter of the shaded region. Okay, so there's one thing we have to be careful about. We're given the angle, that is pi over 4. Then we're given the radius as well. So radius and the angle, and we have to find the perimeter of the shaded region. Basically, this is part of the formulas I was talking about. This is the perimeter. Perimeter of this is going to contain 2 things. Perimeter, we know, is basically the length around a shape or a figure. So looking for the perimeter of this is basically finding the length of this line, which turns out to be a chord. Then we find the length of this arc. If we sum it together, that will give us the perimeter of the shaded region. So we've gotten a strategy to solve the question. Now it's our duty to find the length AB and the arc AB. So the length AB is basically the length of a chord. If you know the length of the chord formula, you are good to go. If you don't, then you'd have to find other ways of solving it. I think you can use the cosine rule in this case, or you can use the length of the chord formula. I'm going to use the length of the chord formula. You can also try using the cosine rule. We should get the same answer. So I can say that the perimeter of the shaded region, let me change the ink. So the perimeter is going to be equal to the length of chord plus arc length. The length of a chord is given by 2r sine theta over 2, and arc length is r theta or theta r. Since we know what r is and we know what theta is, we can easily solve the question. So this gives you 2 multiplying 7, so 2 times 7, 2r sine, our angle given was pi on 4, so pi on 4 divided by 2 will be pi on 8, plus pi on 4 multiplied by 7. Let's see what we're going to get with a calculator. Make sure your calculator is set in radians. If it's not, press the shift key menu. If you're using a class-based calculator, you go to angle units and you'll go to radians. If you're using a regular calculator like this one, again you can press shift and menu. Then you'd see RAD, that's the 4th option. Select the 4th option, and we'll set the calculator into radian. Okay, so I'll be using this calculator, the class-based calculator, for most of my calculations today. I have to change this one to 7, not R. That's 7. Since the radius is 7, let's use 7 instead of R. So this becomes 2 multiplied by 7 sine of pi over 8 plus pi over 4 times 7 And that's a 3-mark question, so it shouldn't be that complicated. And the answer we get is 10.855. So to 3 6 figures, we can say that that's equal to 10.9, or we can just write a 10.855. Don't penalize us for this. So the answer to this question is 10.855. So it was quite an easy question. Let's see if we can do question number 2. This didn't provide the drawing for us, and we are supposed to get a drawing for ourselves. A circle has radius of 6 centimeters, and we're also told that the sector of the circle has perimeter of 2 brackets open 6 plus 5 pi centimeters. We have to find the area of the sector. Such an interesting question. So let's try to get a visual representation of this. So there's my center, and let's try to get the sector itself. So okay, so that's what we are talking about. We're told that the radius of the circle is 6. Let's put it there. And the perimeter of the sector has got the perimeter of the sector is 2 brackets open 6 plus 5 pi. So basically the perimeter of a sector is talking about the total length around the shape. So if you are considering this length, let me do it in a different color. So if you are considering this length, how did I go out? So this length, the length of the arc, and this side as well. This is what we're told is giving us 2 brackets open 6 plus 5 pi. So that is the perimeter of the sector. So basically I can say that the perimeter of the sector is equal to the radius plus the length of arc. Then the arc length is theta r. So that is basically theta r. Now if you work out this, you should get 2r plus theta r, and at the same time you can get r brackets open 2 plus theta. So that's the perimeter of a sector. This won't be part of the formulas I'll be giving out, but you can add it to it if you want, so that the formula becomes 8 instead of 7. So we now know that the perimeter of a sector is r brackets open 2 plus theta. We're told the perimeter is 2 brackets open 6 plus 5 pi, so we can easily equate the two of them and see what we can get. So I can say that r 2 plus theta is equal to 2 6 plus 5 pi. So at this point we don't know what's r. Okay, we know what r is. R is 6. So let's put it there. 6 brackets open 2 plus theta equal to 2 brackets open 6 plus 5 pi. There is now a simple linear equation. We should be able to solve this with ease. I can divide everything by 2. So divide this one by 2, divide this one by 2, leaving you with 3 brackets open 2 plus theta is equal to 6 plus 5 pi. Distribute the 3. This gives you 6 plus 3 theta is equal to 6 plus 5 pi. Now subtract 6 from both sides. We should get 3 theta is equal to 5 pi, where theta should be equal to 5 pi over 3. So you take your time and solve this one. But this is not what we are told to find. We were told to find the area of the sector. So area of the sector is going to be part of the formulas that we're given. So area of sector is equal to 1 over 2 r squared theta. So this will give you 1 over 2. The radius was given as 6, so times 6 squared. Then theta we calculated it as 5 pi over 3. So let's call on the calculator again. Okay, so 1 over 2, which is 0.5. So 0.5 multiplying 6 squared, which is 36. Then 5 over 3 pi. And that should give you 30 pi. So the area of the sector is 30 pi. And the unit is centimeters, so there should be 30 pi centimeters squared, since we are talking about area. So that is not so complicated. So far I think we are 9 minutes into the video, so let's see if we can solve one or more. One question I think will be fair, so that we solve 3 questions for today. Then the next video we solve under 3. I don't want the video to be too lengthy. I know it's some way when we are dealing with a long video. So yeah. Question number 3. the circles with center C1 and C2 have equal radii of length r. Then we're told that the line C1 and C2 is the radius of both circles. The two circles, we're told again, intersect at points A and B. Given that r is equal to 3, find the exact area of the shaded region. This is quite an interesting question. So we really need to think for this question. I think it's not straightforward. So let's do the thinking together. From this point to this point is the radius of the first circle, and from this point to back to C1 is also the radius of the second circle. But if you have to watch carefully, from this point to this point is also the radius of the first circle. So this, when I say the first circle, I'm talking about this one. Let me try to use a red to trace it so that I can just reference it. Okay, so the red circle, that is the radius from C1 to A, is also a radius from the red circle because it starts from the center of the circle and goes to the circumference of the circle, therefore that is the radius. Then from the black circle, we can also say that from C2 to A is also the radius of the circle. And the question told us that the radii are equal, so this side is equal to this side, and at the same time equal to this side. This is giving us an equilateral triangle. So once you've got an equilateral triangle, we can easily tell the angle it makes. And for equilateral triangle, each angle is 60 degrees, but notice that we are not working in degrees, we are working in radians. So let's just put the 60 degrees. I think it's easier that way, but I'll change it to radian anyway. So 60 degrees. And with that said, I don't really need the other side, but let's put it there. The same analogy. This is a line, and this side will give you 60, 60, 60. So 60 degrees over here, 60 degrees over here, and 60 degrees over here. Now that we've established that this is 60 degrees, I would like to clean a portion of it and focus on the question itself. Let me clean a portion of this. So we now know that this full angle, the angle of the sector is not 60, it's actually 120. It's going to be double of that, so this full angle is 120 degrees. And if we are talking about 120 degrees, it's some way, so let's change it to radians. And to change to radians is quite simple. You divide the answer by 180, then you add pi to it. So 120 or 12 divided by 18 is going to be 2 over 3. So 120 degrees in radians is going to be 2 over 3 pi. So the angle over here is 2 over 3 pi. Let's change this to 2 over 3 pi. So 2 over 3 pi. Okay. Let's see if we can find a strategy to find the area. Now, if you again watch carefully, if you are to join the line A to line B, this portion of the red circle, that is a segment of the red circle. Focus on just the red circle and let's see. The shaded region is actually the black circle and the red circle. So there's the segment for the red circle. And if you know the formula for segments, you are good to go. So I think the same area is going to be for the other circle because the radius, the radii, we were told that are equal. So whatever we get for the first circle, we're going to get the exact same thing for the second circle. By the way, let's find the area of the segments over there. So the area of the segments is going to be equal to 1 over 2 r squared theta minus sine theta. So that's the area of the segment. This will be part of the 7 formulas I would advise you know. So again, it will be either to your left or to the right of the screen. It will be there throughout the lesson. So okay, we know the radius of the circle, don't we? I think, yeah, we know the radius to be 3. We are given the radius to be 3. And we've already found our theta to be 2 over 3 pi. So this should be 1 over 2. The radius is 3, so 3 squared. Then theta is 2 over 3 pi. minus sine theta. Sine theta is going to be sine 2 over 3 pi. Okay, so we can input this on the calculator. 0.5 times 3 squared is 9, so that we save some time. Then we've got 2 pi over 3, so 2 pi over 3 minus sine 2 pi over 3. Okay, so this is not giving us an exact form, so you have to be very careful. Let's do it bit by bit, otherwise you would mess up everything. Note that we are supposed to get the exact form, so if we write that one, that is obviously not the exact form. Let's do it bit by bit. The first one would be 9 over 4, so 9 over 4 into bracket 2 over 3 pi. Then let's do sine 2 over 3, so sine 2 over 3 pi. This is equal to set 3 over 2, so set 3 over 2. We can now distribute, and if you do that, 9 over 4 times 2 over 3, 2 goes into this 1 and goes into this 2 times. Then 3 goes into this 1 and goes into this 3 times. But if you don't want any trouble, just get your calculator. I don't know why you do this offered when it's a calculator question. So don't worry yourself with these calculations when you can use a calculator for it. It's a good practice to do it without a calculator though, but come on, like, we are fighting for accuracy here, so yeah, I think we can do without that. So 9 over 4, how is this 9 over 4? I think 9 over 2, I missed something. Yeah, you see, I missed something. There's 9 over 2 instead of 9 over 4. Let's do it well. So that is 9 over 2, sorry for that. 9 over 2. So this should be edited. Okay, so 9 over 2 instead. So that is 3 pi. So this will give you 3 pi minus 9 over 2 times. So 9 over 2 times set 3 times set 3 over 2. Come on, we could have done this without a calculator. So that is 9 set 3 over 4. So 9 set 3 over 4. Okay, so that is the area of this segment, the red one. And if you check the other circle, let me name that circle a blue circle instead. So let's say this blue circle. It's going to be the exact thing we did for the red circle. So if you can find the segment for the blue circle, which I can assure you that it's going to be the exact thing, since the radii are the same, that is what we should be expecting. If you look at that one carefully too, this forms part of the segment of that blue circle, and that segment is going to be equal to the segment of the red circle. So to find the total area, so the total area is going to be equal to 3 pi minus 9 over 4 set 3 plus 3 pi minus 9 over 4 set 3. And if you do your sets correctly, I think this should be 3 pi plus 3 pi should be 6 pi, double of 3 pi. Then 9 over 4 plus 9 over 4 is going to be 2 times 9 over 4. Therefore, that should give you 9 over 2. Then that is a set 3. So the answer to the question should be this, and it should be in centimeters squared or units squared. This wasn't given as a unit, so units squared. Okay, units squared. That is fine. We've done 90 minutes. Okay, the last question for question number 4. I think that's the last question. We were told that circle with center C1 and C2 have equal radii and the length r centimeters. C1 and C2 is the radius of both circles. I think we've done this already. We're told to find, given that the perimeter of the shaded portion is 4 pi, come on, find the value of r. Okay, so the perimeter is 4 pi. So if you look at they are basically telling you that if you are to sum up the length around the shaded portion, you are supposed to get 4. So let's do the blue one and let's do the red one. So if they are going to be the same, it means that the arc length of the red one should be basically 2 pi, since everything is 4 pi, and the other side should also be 2 pi. Now that we know the arc length, and we already know that the angle over there was 2 pi over 3, I think we calculated for before, 2 pi over 3, we can use that one to find the value of r. So the arc length for the red one, so length of arc, let me change the, okay, so length of arc is equal to 2 pi, and at the same time length of arc, the formula for length of arc is r theta. We know what theta is and we know what the length of arc is, so this should be quite simple. So 2 pi should be equal to the radius, which we don't know, but we know that the theta, we calculated it earlier and we got it as 2 over 3 pi, so let's write the 2 over 3 pi over there. So 2 over 3 pi, and you do some manipulations. Let's see what you get. First, the pi's can cancel out, so we've got 2 equal to 2 over 3 r, and r should be equal to 3 multiplied by 3 divided by 2. So but let's do it bit by bit. I can get rid of the denominator, multiplied by this, then r should be equal to 3, and that answers that question. This was relatively easy. So that will be all for this video. It's 20 minutes, I don't want it to go beyond. We'll continue the rest in another video. So bye for now. Expect the follow-up of this video.